Hi guys, Mr. Janowski again. This is part 2 of chapter 35, homework 3, problem 6. So in the first part we did A, B, and C. We found the equivalent resistance seen by the battery, the current leaving the battery, the power used by the entire circuit. Um, so that was all of this stuff here. And then in this part we're going to find the voltage drop across each resistor, the current through each resistor, and the power used by each resistor. So here's what I did in the first video. We did all this, simplified the circuit, did all the resistances, yada, 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 all the way down to, let me get my laser pointer, all the way down to this guy. And then it was just Ohm's law to get the current. We did all that. We got the equivalent resistance. Once we knew the resistance, we knew the voltage. Then it was just Ohm's law to get the current. And once we had the current and the voltage, it was just Watt's law to get the power. So we did that. Now we have to go backwards and figure out how to do all of the other little things. So here's what I did: is I took all of this math away. I redrew this with just the equivalent circuits that we had. And what we're going to do is kind of start at the end and go backwards. And we are just going to Ohm's law the hell out of this. This is kind of the brute force, straight ahead way of doing this. Um, so where were we? Here was our last, most simplified circuit, just with a battery, one equivalent resistance. We knew the current leaving the battery, and we knew the voltage. So what we're going to do is now work backwards through all of the intermediate circuits that we had done. So here was the second to last intermediate circuit. So what's going on here? What do we know? Do we know the voltage across each resistor? Do we know the current? Well, what we know is that here, we had I of 0.03495 amps leaving. So that's still going on here. That is the current leaving the battery. So what that means is that current is going to go through both of these resistors. So in both cases, I know what the I is. So I up here is going to be 0.03495 amps, and I down here is also going to be 0.03495 amps. Okay, so I know the I's and I know the R's. Your gut should be telling you, if you know I and you know R, you have to do Ohm's law, figure out what V is. All right, so what's the voltage going to be, like the voltage drop across this resistor? All right, well, let's take I is 0.03495 times 186.6. It should be 6 repeating. All right, so the voltage we get up here is going to be 6.523999, so 24 volts. So that's that voltage. And the voltage we have down here is going to be 0.03495 times that resistance, 500. So we get 17.475 volts. Okay, so I have that current, that resistance. You'll notice, by the way, that this voltage and this voltage, minus a tiny bit of rounding, those guys add up to 24 volts. They have to. All right, so we got that. Now let's back it up and go to the one prior to this. So what do we know here? Well, this 500 ohm resistor is actually already the same thing. It's still the same thing. So I do already know what I is here. I is equal to 0.03495 amps, and V is equal to 17.475 amps. All right, I'm sorry, volts. Let me write that V again. Volts. All right, so maybe I could have gotten away without doing that step there, but I am showing you the brute force way of doing this. So that's what's going on down here with the 500 ohm resistor. What's going on up here? Do I know the current going through each of these branches, or do I know the voltage across this whole thing here? Well, we still have 0.03495 amps coming here, but it's going to split. So what that means is I don't actually know the current going through the top branch with the 400 ohms or the bottom branch with the 350 ohms. I know that they'll add up to 0.03495 amps, but I don't know what either one of them is. What I do know is that if my voltage, look back at the previous one, from this point over to this point is 6.524 volts, well, then I know that's the voltage across this guy here. Like that's the voltage from here to here. Okay. So what that means is I do know this voltage. So this voltage is 6.524 volts, and this voltage down here is also 6.524 volts. All right, so now I know voltages and I know resistances. I can figure out I. This is just going to be Ohm's law. All right, so V equals IR. That means I must be V over R. All right, so I up here, I guess I have room to do it right here. I is going to be 6.524 volts over R, which is 400 ohms. So 6.524 divided by 400. All right, I up here through the 400 ohm resistor is 0.01631 amps. And I down here through the 350 ohm one, sorry, that's an I, is going to be 6.524 volts divided by 350 ohms. So 6.524 divided by 350. So that's going to give me 0.01864 amps. All right. So now I just Ohm's lawed everything up here. You'll notice, by the way, that those two currents I just got, that one up there and this one down here, if I add them together, they have to add up to 0.03495. That's KCL, Kirchhoff's current law. So I know those guys there. Good. So now I've got to wind this back up to this last circuit up here, which is, the one we started with. All right. Well, let's start at the bottom. So what's going on here at the bottom? Well, I know the current leaving the battery is 0.03495 amps. It's going to go here, split, do some things, and then it comes back together. So I do know the current here coming through R4. This is 0.03495 amps, and then that current's going to come down along here. And I also know this current, 0.03495 amps. Okay. And once again, I don't know what's going on up here with this top branch. Actually, let me skip that. Let me do the bottom one, because we do know the bottom one. All right. R3, this 350, we actually did figure this out on the previous one. We do know that the I at this point, I'm running out of room here, but I3 is this number, 0.01864 amps, and we'll call it V3. That voltage is 6.524 volts. So I did figure that out. I could do Ohm's law. I'll do it right here. If I want to know the voltage across R4, okay, well, that's just going to be Ohm's law again, 0.03495 amps times the resistance of 200 ohms. Okay, so this, let's call it V4, 0.03495 times 200, 6.99 volts. And down here, this is going to be 0.03495 amps times 300 ohms. 0.03495 95 times 300. And I've got 10.485 volts for that one. Okay, so now I know, what do I know? I know I5 and V5. I know I4 and V4. I know I3 and V3. Now we have to figure out what's going on up here with R1 and R2. At this point, I do know the voltage across the whole thing. The voltage across the whole thing is 6.524, but that's not going to be the thing that helps me. What I figured out here is that I've got 0.01631. So that's the current coming through here, 0.01631 amps. That current coming up here through this branch, well, that's going to be the one that's going through both of these guys. So what that tells me is, let me call it I1 is equal to 0.01631 amps. So that's I1. That's also going to be what I2 is, because that current's going to come through here, through R1, then it's going to go through R2. So let me call it I2 over here, is also 0.01631 amps. All right, so I know the R's, I know the I's, I can get the V's. So it's just going to be Ohm's law. I'm going to skip writing out the math here. But 0.01631, so that's I1 times R1 is 250. So this voltage ends up being 4.0775. I'll just call it 7. Yeah, I'll write it out. 75 volts. Okay, so that's the voltage across R1, and the voltage across R2 is going to be 0.01631 times R2 is 150 ohms. So here I have 2.4465 volts. And you'll notice that if I were to add up V2, 2.4465 volts, plus V1, 4.0775 volts, I'm going to get some number that's got to be very close to 6.524 volts. That's got to be the same. That's the voltage across the whole thing, both resistors in series. So if I add up the voltage across either one, it has to add up to that number. So yeah, look what we have at the beginning. I have I1, V1, I have I2, V2, etc. I know all the currents and all the voltages across all of these guys. So yeah, I filled out all of the things. Well, not quite all of the things. You still need to do PIV, P equals IV. And this video is getting long, so I'm just going to skip doing all of them. Right, how would we figure out these? Well, I've got room to do it here for R2. Let me say P2 is going to be equal to I2 times V2. All right, so 0.01631 times 2.4465 is equal to 0.0399. And this is a power, so this would be watts. So the rest of this would just be the game of taking all of your currents and voltages and just doing Watt's law, PIV, P equals IV, to figure out all the powers. And then you write them down, and then you have everything. So this is different than how I usually do this. This is kind of the brute force way, where we're just starting at the end and working backwards and just figuring out everything. We're just doing Ohm's law again and again and again, and trying to figure out every current, every voltage at every equivalent resistance throughout the whole, throughout all the intermediate circuits. Kind of brute force, but it works. It's very straightforward. Hopefully, it makes sense.